Thank you for joining another math lesson hosted by Book and Table. I am your math tutor, Maurice Wright, and in this chapter we are going to review how to factor polynomials. We'll discuss how you can go about finding the greatest common factor of two numbers. We'll review how to factor a polynomial by removing the greatest common factor. We'll take a look at the grouping method to review how to factor polynomials with four terms. We'll review the two methods of factoring trinomials. One, when the leading coefficient is equal to 1. The second method is when the leading coefficient is not equal to 1. We'll review how to factor the difference of two squares, and then we'll wrap up the chapter by reviewing how to factor both the sum and the difference of two cubes. Should you have any follow-up questions, feel free to leave them in the comment section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. So let's kick things off by reviewing quadratics. A quadratic is a second-degree expression, or one that has a variable with a power of 2. So ax squared plus bx plus c is equal to 0 is the standard form of a quadratic equation. The leading coefficient of our quadratic term cannot be equal to 0. Otherwise, x squared would not exist. 0 times anything would be 0. And thus we would not have a variable with an exponent of 2. So a cannot be equal to 0. B can be equal to 0. So you can have a quadratic that just has one variable, and that variable has an exponent of 2. And you'll notice here how we've written this expression. We have the term with the largest exponent further to the left. This variable has an exponent of 1, and this term does not have a variable. So you'll see the standard form of a polynomial has the terms with the highest degrees furthest to the left. So for example, if we had 3x squared minus 4x plus 7 is equal to 0, this is the standard form of the polynomial. We have a degree of 2, a degree of 1, and a degree of 0. But if we move the quadratic to the middle of our expression, such as this example, this would no longer be in standard form. 6x minus 5x squared minus 2 is equal to 0 is not standard form of the polynomial. In order for this to be in standard form, negative 5x squared would need to be furthest to the left. And now this equation is in standard form. The reason I bring this up, throughout this chapter we will be dealing with quadratics, and when you see them they will be in standard form. This is just the way in which we usually write out these expressions to keep things consistent. Now, the solutions of a quadratic equation, also known as the roots or zeros, are the x values where the function is equal to 0. So for example, this parabola that represents a quadratic equation has a solution here. So there's one x value where the function has a value of 0. For this function or parabola, we see that it has two solutions. And for this one, we see that it does not cross our x-axis, so this one has 0 solutions. Now, why is this important? The reason why you are factoring quadratics specifically is because throughout algebra, you are trying different ways to figure out the values where the function crosses this x-axis. So this is why factoring polynomials, specifically quadratics, comes up very frequently throughout your algebra chapters. We won't be solving the quadratics in this chapter, we'll just be focusing on factoring them, but I wanted to make sure that you understood why you needed to know how to factor polynomials, specifically quadratics. Now, in order to understand how you find these solutions, we must review the zero product property. The zero product property states that if the quadratic is equal to 0, then either one or both of the factors are equal to 0. So let's say you had some quadratic expression and it's equal to 0, and you wanted to factor this expression. When you do so, you would have one factor times another factor, and we know that the product is equal to 0. So by knowing that one or both of the factors must be equal to 0, in order to solve for x, or to find the solution or solutions, we set each factor equal to 0 and solve for x. So one of the factors, x minus d, we set that equal to 0 and solve for x. To do so, we add d to both sides, giving us x is equal to some number d. So that would be one solution. And another potential solution we find by doing x minus e is equal to 0. So we add e to both sides, giving us x is equal to some number e. So this is how you would go about using the zero product property to find the solutions or the x values where the function crosses the x-axis. So this is why we want to go about factoring quadratics specifically. Now, let's discuss factors. The factors of a product are the numbers and variables that can be multiplied to get the product. So let's say we had the number 20. You can get to 20 by multiplying 1 times 20. So these are both factors. You can get to 20 by multiplying 2 times 10. So these are both factors. And you can get to 20 by multiplying 4 times 5. So these are both factors as well. So these are the numbers that you can multiply to get to 20. So all 6 of these numbers are factors of 20. Now let's say you had a term that had both numbers and variables. Negative 15 x squared y to the 5th is a product because you are multiplying negative 15 times x squared and multiplying these times y to the 5th. Right? So it's a result of multiplication, so it's our product, which lets us know that the individual pieces of that product are our factors. So the factors of negative 15 x squared y to the 5th are negative 15, x squared, and y to the 5th. Now that is for a monomial. For polynomials, you can get the factors several different ways. In this case, we have factors 4x being multiplied times the binomial negative 3x squared y plus 5, and that would give you a product of negative 12x cubed y plus 20x. You can also get a trinomial that has the variable twice, x squared plus 2x minus 3, and the factors of that polynomial would be x plus 3 times x minus 1. So again, we would multiply these two terms, making those our factors, and we get this expression as a result, making it our product. So there will be several different types of products that we will run into throughout the remainder of this chapter, and we'll discuss how we go about finding the factors for said product or expression more specifically. Now let's move on to discuss the greatest common factor. To do so, we must first review the factor tree. A factor tree is a diagram used to determine the prime factors of a positive number. So let's say we had the positive number 40, and we wanted to determine the factors of 40. We want to break 40 down until we have all of the prime factors of 40, the factors that cannot be broken down any further. So we have 2 times 20 would give us 40. 2 is a prime number. 20 is not. So we'll try to break up 20 further. 20 can be broken up into 2 times 10. 2 is a prime factor, so that's ideal. 10 can be broken up further into the product of 2 times 5, both of which are prime numbers. So since we have prime factors at the bottom of this tree now, it cannot be factored any further, which lets you know this prime factor tree is done. And you'll notice that you'll be able to multiply the prime factors to get the original number. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. Let's say we had a different number, 120. Let's take a look at the factor tree for this number. Since it is an even number, we can split it in half, giving us 2 times 60. 2 is a prime factor, so we can leave that side. So we'll take a look at 60. 60 can be broken up into 2 times 30. 2 is a prime factor, so we'll leave that side. We'll break up 30 into the product of 2 times 15. 2 is a prime factor, so we'll leave that side. 15 is not, so we'll break that down further into the product of 3 times 5. And now we have prime factors at the end of our tree. And we see 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. And 24 times 5 is 120. So we have factored 120 as far as we can. Now if we have two numbers, 40 and 120, you'll notice that since they're both even, we were able to start breaking those numbers down by dividing them by 2. And if you have an odd number, you want to try dividing it by an odd prime number, such as 3, 5, or 7 to start. So for example, here we had 15. 15 can be divided by 3. That would give us 3 times 5. So that is how you break down a number to get its prime factors. Now let's discuss how you would go about finding the greatest common factor between two numbers. Now, the greatest common factor is the largest number that can divide two numbers. It's a common factor, and it's the greatest or the largest one. So let's take 40 and 120, for example. Let's say you're asked to find the greatest common factor and check the answer for 120 and 40. So you start step 1 by creating a prime factor tree for each number. They're both even numbers, so you can start by dividing them both by 2. 120 is equal to 2 times 60. 60 is equal to 2 times 30. 30 is equal to 2 times 15. 15 is equal to 3 times 5. For 40, we have 40 is equal to 2 times 20. 20 is equal to 2 times 10. And 10 is equal to 2 times 5. So once you create a prime factor tree for each number, the next thing you want to do, step 2, is circle each prime number that is common to both factor trees. So we have 3 2's that are common to each factor tree. We do not circle this 3 since this factor tree does not have a 3. And we circle this 5 since this factor tree also has a 5. And now that you've circled each prime factor that is common to both, the third step is to multiply these numbers in one of the factor trees. You don't need to multiply it twice. Multiply the prime factor circled in one of the trees to find the greatest common factor. So the greatest common factor is going to be equal to 2 times 2 times 2 times 5. 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. So the greatest common factor between 120 and 40 is equal to 40. Now to check this answer, we want to divide both of the original numbers by the greatest common factor, because if you divide a number by a factor, you should get an integer value. You should not get a decimal. When we divide 120 by 40, we get 3. And when we divide 40 by 40, we get 1. So we get integer values for both. So this helps us confirm that we did find the greatest common factor. So those are the steps you would take to find the greatest common factor of two numbers. Let's now have you complete a few practice questions. Question number 1. Find the greatest common factor of 65 and 15. Question number 2. Find the greatest common factor of 72 and 16. And question number 3. Find the greatest common factor of 180. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. You were asked to find the greatest common factor of 65 and 15. Step 1, create a prime factor tree for each number. 65 can be divided by 5. 5 times 13 gives you 65. 5 is a prime factor, and 13 is a prime factor as well. So this is the prime factor tree of 65. 15 is divisible by 3. 3 times 5 gives you 15. So this is the prime factor tree of 15. Now the second step, you want to circle each prime number that is common to both factor trees. And in this case, that is just the number 5. 13 is not a factor of 15. And 3 is not a factor of 65. Now that we've done that, we are done. Normally we would multiply the numbers that are circled in the prime factor tree, but we just have one number circled in each, so that is our greatest common factor. And we can check this answer by dividing the original numbers, 65 and 15, by the answer, 5, to make sure that we get an integer value. 65 divided by 5 is equal to 13. 15 divided by 5 is equal to 3, thus confirming that our greatest common factor of 65 and 15 is equal to 5. Question number 2. You are asked to find the greatest common factor of 72 and 16. So step 1, create a prime factor tree for each number. 72 is an even number, so we start by dividing it by 2, giving us 2 times 36. 36 is an even number, so we divide it by 2, giving us 2 times 18. 18 is an even number, so we divide it by 2, giving us 2 times 9. 9 is an odd number, so we consider dividing it by 3 first, and it can be divided by 3, giving us 3 times 3. And now that we have all prime factors at the end of our tree, this prime factor tree is completed. Let's take a look at 16. 16 is an even number, so it can be divided by 2, giving us 2 times 8. 8 is an even number, so it can be divided by 2, giving us 2 times 4. And 4 is an even number, so it can be divided by 2, giving us 2 times 2. And now that we have all prime factors at the end of our tree, this prime factor tree is now completed as well. So the second step is to circle each prime number that is common to both factor trees. And we'll see that each prime factor tree has a total of 1, 2, 3 2s. We do not circle this 2 because this tree does not have a fourth 2. And we do not circle either of these 3s because this factor tree does not have a single 3. So these 3 2s are the only numbers that are common to both factor trees. And now the third step, we'll find the greatest common factor by multiplying the numbers that are circled, giving us the greatest common factor is equal to 2 times 2 times 2, which would be equal to 8. And now that we found the greatest common factor, we want to check the answer by dividing the original numbers, 72 and 16, by the answer, 8, to make sure that we get integer values when we do so. 72 divided by 8 is equal to 9, so that works. And 16 divided by 8 is equal to 2, so that works. Thus confirming that the greatest common factor of 72 and 16 is equal to 8. And now question number 3. You are asked to find the greatest common factor of 180. Step 1, create a prime factor tree for each number. 100 is even, so we can start by dividing it by 2, giving you 2 times 50. 50 is even, so you can start by dividing it by 2, giving you 2 times 25. 25 is odd, so you want to start by trying to divide it by 3, which you cannot. Then you try dividing it by 5, which you can, giving you 5 times 5. We have all prime factors now at the end of our tree, so that one is done. For 80, we have 2 times 40. 40 is even, so you can divide it by 2, giving you 2 times 20. 20 is even, so you can start by dividing it by 2, giving you 2 times 10. 10 is even, so you can divide it by 2, giving you 2 times 5. And now we've completed this factor tree as well. So now we can find the greatest common factor by circling each prime number that is common to both factor trees, and then by multiplying those numbers that are circled, giving us the greatest common factor is equal to 2 times 5, which would be 2 times 2, which is 4. 4 times 5 would be equal to 20. So the greatest common factor between 100 and 80 is equal to 20. And now to check the answer, we want to divide both 100 and 80 by 20 to make sure that we get whole numbers as our quotient. 100 divided by 20 is equal to 5, so that works. 80 divided by 20 is equal to 4, so that works. So the greatest common factor of 100 and 80 is equal to 20. So that is how you go about finding the greatest common factor of two numbers. Let's now discuss how you would go about factoring a quadratic by removing the greatest common factor. To do so, we must first discuss the concept of distribution. So let's say we had 2x times x plus 3. A term on the outside of a set of parentheses is distributed to each term inside of the parentheses. So 2x times x would give you 2x squared, and 2x times 3 would give you positive 6x. And once the term is distributed, then it is a common factor in each term of the product. So 2x can be removed from 6x, and 2x can be removed from 2x squared. So reverse distribution is what we will use to find the greatest common factor of a quadratic with a single variable. So if you had 2x squared plus 6x and wanted to remove the greatest common factor, the first thing you do is remove the largest number that is a common factor of the coefficients. In this case, our coefficients are 2 and 6. So the largest common factor between 2 and 6 is 2. If you're not sure, you can create a prime factor tree for each number. So you can remove 2, and then you go to the like variables. In this case, we have just a single variable x. Later in the chapter, we'll be removing greatest common factors for terms with multiple variables. But in this case, we have x squared and we have x. X squared is not common to both. This term only has one x, but x is common to both. We have two x's here, we have one x here, so we can remove one x from both terms. So x is our greatest common factor between x squared and x. So once we've removed the largest factor of the coefficients and the greatest common factor of our variable, we wind up with 2x on the outside. So our factors would be 2x and x plus 3 for 2x squared plus 6x. Now, let's say you're asked to factor by removing the greatest common factor and check the answer for 4x squared minus 12x. How would we go about doing so? Step 1, remove the greatest common factor from the coefficients. So the greatest common factor between 4 and negative 12 is 4. We then, step 2, remove each variable and the largest exponent that is common to each term. X is common to each term, not x squared, since this term does not have two x's. So the greatest common factor between these two terms is 4x. And now to figure out the second factor, you want to divide each term in the original polynomial by the greatest common factor, 4x. And when you do so, 4x squared divided by 4x would give you x. 4 divided by 4 is 1. X squared divided by x is equal to x. 1 times x is just x. And now you divide the second term by 4x, giving you negative 12 divided by 4 is negative 3. X divided by x is 1. Negative 3 times 1 is negative 3. So we wind up with the factors of 4x times x minus 3 as our answer. And now step 4, check the answer by multiplying the factors. If we multiply these two factors, we should wind up with a product of 4x squared minus 12x. 4x times x is 4x squared. 4x times negative 3 is negative 12x. So we do wind up with our original polynomial, which confirms that 4x times x minus 3 are the factors of 4x squared minus 12x. So that is how you factor by removing the greatest common factor for polynomials with a single variable. Let's have you complete a few practice questions. Question number 1, factor by removing the greatest common factor and check the answer for 14x squared minus 7x. Question number 2, factor by removing the greatest common factor of 16x squared minus 12x and check the answer. In question number 3, factor by removing the greatest common factor of 30x squared plus 45x and check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we wanted to factor 14x squared minus 7x by removing the greatest common factor. Step 1, remove the greatest common factor from the coefficients. And we have 14 and negative 7. Common factor is 7. We then take a look at our variable, x squared and x. We remove each variable and the largest exponent common to each term. X, the largest exponent common to each is 1. We have 1x here. We have 2x's here. 1 is common to both. So 7x is the greatest common factor of 14x squared minus 7x. To find the second factor of this expression, we want to divide each term in the original polynomial by the greatest common factor, 7x. When we do so, we get 14 divided by 7 is 2. X squared divided by x is equal to x. This exponent 2 subtracts this exponent 1 to give us an exponent of 1. We then divide the second term in our original polynomial by the greatest common factor, giving us negative 7 divided by 7 is negative 1. X divided by x is 1. Negative 1 times 1 is negative 1. So the factors of 14x squared minus 7x are equal to 7x times 2x minus 1. Step 4, check the answer by multiplying the factors, giving us 7x times 2x, which is 14x squared, and 7x times negative 1 gives us negative 7x. So this confirms that the factors of 14x squared minus 7x are equal to 7x times 2x minus 1. So that is the answer to question number 1. Let's have a look at question number 2. We were asked to factor 16x squared minus 12x. Step 1, remove the greatest common factor from the coefficients, 16 and negative 12. That would be 4. Step 2, remove each variable and the largest exponent common to each term. We have x squared in one term and x in the other term. So the largest x would just be x. That is common to both. So the greatest common factor of 16x squared minus 12x would be 4x. And now to find the second factor, the third step is to divide each term in the original polynomial by the greatest common factor, 4x. When we do so, we get 16 divided by 4, which is 4. X squared divided by x is equal to x. 2 minus 1 would be x to the first. And now we divide the second term, negative 12x, by 4x, giving us negative 12 divided by 4, which is negative 3. X divided by x is equal to 1. 1 times negative 3 is negative 3. So when we factor 16x minus 12x, we wind up with 4x times 4x minus 3. The fourth step, we can check the answer by multiplying the factors, 4x times 4x minus 3, giving us 4x times 4x, which is 16x squared, and 4x times negative 3 would give us negative 12x. So this confirms that when you factor 16x squared minus 12x, you wind up with 4x times 4x minus 3. So that is the answer to question number 2. Let's now have a look at question number 3. We were asked to factor 30x squared plus 45x by removing the greatest common factor. So step 1, we start by removing the greatest common factor of the coefficients, 30 and 45. And the greatest common factor of those two numbers would be 15. Again, if you weren't sure of this, you can create a prime factor tree for both these numbers. Step 2, remove each variable and the largest exponent common to each term. We have x squared and x. X is common to both, not x squared. So x is a part of our greatest common factor. The third step, in order to find the second factor of this expression, you want to divide each term in the original polynomial by the greatest common factor, 15x, giving us 30 divided by 15, which is 2. X squared divided by x is x. And now the second term, 45 divided by 15 is positive 3. X divided by x is 1. 1 times positive 3 is positive 3. We wind up with 15x times 2x plus 3. And now we want to check the answer by multiplying the factors, giving us 15x times 2x, which is 30x squared. And 15x times 3 would give us positive 45x. So since this is our original polynomial, that confirms that when we factor that polynomial, we wind up with 15x times 2x plus 3. So that is how you would factor the quadratic by removing the greatest common factor. Let's now review how you would go about removing the greatest common factor from terms that have multiple variables. Again, this is similar to when you were removing the greatest common factor with a single variable. Distribution is when a term on the outside of a set of parentheses is distributed to each term inside of the parentheses. So if you had 2x squared y to the fifth times 3 minus 4x y to the third, this term on the outside would be multiplied times each term on the inside, giving us 2 times 3, which is 6. X squared y to the fifth remain the same since this term doesn't have any x's or y's. 2x squared y to the fifth times negative 4xy to the third would give us 2 times negative 4, which is negative 8. And when we are multiplying the variables, we add the exponents. X squared times x would give us x cubed. 2 plus 1 equals 3. And y to the fifth times y to the third gives us y to the 5 plus 3, which is y to the eighth. So if this term can be distributed to each term on the inside here to give us this final product, reverse distribution is how we would remove the greatest common factor from this polynomial. We first want to remove the largest number that is a common factor of the coefficients first. Our coefficients are 6 and negative 8. So 2 is the greatest common factor of those coefficients. So we can take that out. We then want to go to each individual variable. So we'll start with the x's. we have x squared, and we have x to the third. X squared is common in both. You have 2 x's in both. You do not have 3 x's in both. So x squared is the greatest common factor, so we take that out. And then you go to the next variable, which in this case is y. We have y to the 5th and y to the 8th. So the greatest common factor of the y's is y to the 5th, since you have 5 y's in each, but you do not have 8 y's in each. You only have 5 here. So when you remove the greatest common factor of y to the 5th, you take that out. And the two factors for 6x squared y to the 5th minus 8x cubed y to the 8th would be 2x squared y to the 5th. And the second factor would be 3 minus 4x y to the 3rd. So removing the greatest common factor from an expression that has multiple variables is the same exact process of removing the greatest common factor of an expression that has a single variable throughout the terms. So let's take a look at this example. Let's say you are asked to factor by removing the greatest common factor and then check the answer for negative 32 x to the 4th, y to the 10th, z to the 6th, plus 8x to the 7th, y to the 5th, minus 24 x to the 3rd, y to the 4th, z squared. So the first step, same as before, remove the greatest common factor from the coefficients. So the coefficients, we have negative 32, positive 8, and negative 24. Each of these three numbers can be divided by 8. We then take a look at our first variable, x. So the second step, remove each variable and the largest exponent common to each term. So when we look at our x's, we have x to the 4th, x to the 7th, and x to the 3rd. X to the 3rd is the largest x that we can take out of each one, since it is common in all three. X to the 4th, for example, cannot be removed, since this term does not have 4 x's to take out, but it does have 3. We then look at the next variable, y. We have y to the 10th, y to the 5th, and y to the 4th. 4 y's are common in all three, so we can remove y to the 4th. And now we look at our z's. Z to the 6th is in the first term. There is no z in the second term, and we do have a z in the third term. But since z is not common in all three terms, then there is no z in the greatest common factor, since it is not common here. So our greatest common factor is 8x cubed y to the 4th. And now we can figure out the second factor by dividing each term in the original polynomial by the greatest common factor, 8x cubed y to the 4th. When we do so, we get negative 32 divided by 8 would give us negative 4. X to the 4th divided by x cubed is equal to x to the 4 minus 3, which is x to the 1, or just x. We then look at our y's. Y to the 10th divided by y to the 4th is equal to y to the 10 minus 4, which should be y to the 6th. We have z to the 6th divided by no z's, so we keep z to the 6th. And now that we've divided the first term by our greatest common factor, we then move on to the second term. 8 divided by 8 is equal to 1. So we do not need to show that. X to the 7th divided by x to the 3rd is equal to x to the 7 minus 3, which would be x to the 4th. And y to the 5th divided by y to the 4th is equal to y to the 5 minus 4, which is y to the 1st, or just y. And when we divide the third term, we get negative 24 divided by 8, which is negative 3. X cubed divided by x cubed is 1, so we can remove the x. Y to the 4th divided by y to the 4th is equal to 1, so we can remove the y's. And we have z squared divided by no z's, which remains z squared. So when we factor the polynomial by removing the greatest common factor, 8x cubed y to the fourth, we wind up with the factors 8x cubed y to the fourth times negative 4x y to the sixth z to the sixth plus x to the fourth y minus 3z squared. And to check the answer, you want to multiply the factors. So we have 8 times negative 4, which is negative 32. X to the third times x would give you x to the 3 plus 1, which is 4. Y to the fourth times y to the sixth gives you y to the 4 plus 6, which is 10. And z to the sixth times nothing is just z to the sixth. Now we multiply the greatest common factor times the second term in here. 8 times positive 1 is positive 8. X to the third times x to the fourth is equal to x to the 3 plus 4, which is 7. Y to the fourth times y is equal to y to the 4 plus 1, which is 5. And for the last term, we get 8 times negative 3, which is negative 24. X cubed times nothing is x cubed. Y to the fourth times no y's is y to the fourth. And z squared times no z's is z squared. So since our final polynomial matches our original polynomial, that confirms that these are the factors of our polynomial. So that is how you would go about factoring a polynomial with multiple variables by removing the greatest common factor. Let's now have you try a few practice questions. So factor by removing the greatest common factor. Question number 1, 15x cubed y squared minus 9xy plus 12x to the fourth yz squared. Question number 2, factor by removing the greatest common factor of negative 8x to the fifth y to the seventh plus 6x cubed y to the fourth minus 2x to the fourth y cubed, and then check the answer. In question number 3, factor by removing the greatest common factor of 20x cubed y cubed minus 5x y cubed plus 15x squared y to the fourth minus 10x to the fifth y to the seventh, and then check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. You were asked to factor 15x cubed y squared minus 9xy plus 12x to the fourth yz squared by removing the greatest common factor. Step 1, remove the greatest common factor from the coefficients, 15, negative 9, and 12. And the greatest common factor of these three numbers would be 3. Step 2, remove each variable and the largest exponent common to each term. So we have x to the third, x, and x to the fourth. X is common in all three, so that is part of our greatest common factor. And now y, we have y with an exponent of 2, y with an exponent of 1, and y with an exponent of 1. So the y to an exponent of 1 is common in all three, so we remove that. And for our third variable, z, we only have z in one term. So since it cannot be removed from all three terms, it is not a part of the greatest common factor. So the greatest common factor for this polynomial is 3xy. And now to figure out the second factor for this polynomial, you want to divide each term in the original polynomial by the greatest common factor, 3xy. When you do so, we get 15 divided by 3, which is 5. x to the third divided by x is equal to x to the 3 minus 1, which is 2. And y to the second divided by y is equal to y to the 2 minus 1, which is 1. And now we can move on to our second term, negative 9xy. When we divide that by the greatest common factor, we get negative 9 divided by 3, which is negative 3. X divided by x is 1, so we can remove the x's. Y divided by y is 1, so we can remove the y's, leaving us with just negative 3. And now the third term, we divide it by the greatest common factor. We get 12 divided by 3, which is 4. X to the fourth divided by x is x to the 4 minus 1, which would be 3. And z squared divided by no z's is still z squared. So the factors of this polynomial are 3xy times 5x squared y minus 3 plus 4x cubed z squared. Now step 4, check the answer by multiplying the factors. When we do so, the final product should be our original polynomial. 3 times 5 is 15. X times x squared is x to the 1 plus 2, which is 3. Y times y is y squared. Then we have 3 times negative 3, which is negative 9, times xy. And then lastly, 3 times positive 4 is positive 12. X to the first times x to the third is equal to x to the 1 plus 3, which is 4. We only have one y, so we keep that. And we have z squared, so we keep that. So since our final polynomial matches our original polynomial, that confirms that the factors are 3xy and 5x squared y minus 3 plus 4x cubed z squared. Let's now have a look at question number 2. We were asked to factor by removing the greatest common factor of negative 8 x to the 5th y to the 7th plus 6x cubed y to the 4th minus 2x to the 4th y cubed. Step 1, remove the greatest common factor from the coefficients, negative 8, positive 6, and negative 2. And the greatest common factor would be 2. We then move on to the variables by removing each variable and the largest exponent common to each term. So starting with our x's, we have x to the 5th, x to the 3rd, and x to the 4th. X to the 3rd is common in all three. This one has 4 x's, this one has 5 x's. So they all have at least 3 x's. So that's part of our greatest common factor. And then y's, we have y to the 7th, y to the 4th, and y to the 3rd. Each term has at least 3 y's. So y to the 3rd is a part of our greatest common factor. So the greatest common factor that we removed is 2x cubed y cubed. And now to figure out the second factor, we want to divide each term in the original polynomial by the greatest common factor, 2x cubed y cubed. And when we do so, we get negative 8 divided by 2, which is negative 4. X to the 5th divided by x cubed is x squared. 5 minus 3 gives us 2. And y to the 7th divided by y to the 3rd gives us 7 minus 3, which is y to the 4th. And now we move on to the second term. 6 divided by 2 gives us positive 3. X cubed divided by x cubed is 1, so we can remove it. Y to the 4th divided by y to the 3rd is equal to y to the 4 minus 3, which is 1. So that gives us just y. And now the third term, negative 2 divided by 2 is negative 1. X to the 4th divided by x to the 3rd is x to the 4 minus 3, which is 1. So it's just x. And y to the 3rd divided by y to the 3rd is 1. So we can remove y. So our second factor is negative 4x squared y to the 4th plus 3y minus x. So we get 2x cubed y cubed times negative 4x squared y to the 4th plus 3y minus x. And now to check the answer, you want to multiply the factors. And when we do so, our final polynomial should match our original polynomial. So we get 2 times negative 4, which is negative 8. X cubed times x squared is x to the 3 plus 2, which is 5. Y to the 3rd times y to the 4th is equal to y to the 3 plus 4, which would be y to the 7th. Now we multiply 2x cubed y cubed times 3y, giving you 2 times 3, which is 6. X cubed times no x's is x cubed. Y cubed times y is equal to y to the 3 plus 1, which is 4. And then we multiply the greatest common factor times negative x, giving us 2 times negative 1, which is negative 2. X to the 3rd times x is equal to x to the 3 plus 1, which is 4. And y cubed times no y's is y cubed. So our final polynomial matches our original polynomial, which confirms that the factors we were looking for are 2x cubed y cubed and negative 4x squared y to the 4th plus 3y minus x. And let's have a look at question number 3. You are asked to factor by removing the greatest common factor from 20x cubed y cubed minus 5xy cubed plus 15x squared y to the 4th minus 10x to the 5th y to the 7th. Step 1, remove the greatest common factor from the coefficients. The coefficients are 20, negative 5, positive 15, and negative 10. The largest number that is a common factor to all 4 of those numbers is 5. Step 2, remove each variable and the largest exponent common to each term. We have x to the 3rd, x to the 1st, x to the 2nd, and x to the 5th. Only x to the 1st is common in all 4, so x is a part of our greatest common factor. Then we take a look at the y's. We have y to the 3rd, y to the 3rd, y to the 4th, and y to the 7th. Y to the 3rd is common in all 4. So y to the 3rd is a part of our greatest common factor, which winds up being 5xy cubed. And now since we found the greatest common factor, we want to divide each term in the original polynomial by the greatest common factor. That will help us find the second factor for the polynomial. When we do so, we get 20 divided by 5, which is 4. X to the 3rd divided by x is equal to x to the 3 minus 1, which is 2. Y to the 3rd divided by y to the 3rd equals 1, so that cancels out. We then move on to the second term. Negative 5 divided by 5 is negative 1. X divided by x is 1, so we can remove the x's. Y to the 3rd divided by y to the 3rd is equal to 1, so we can remove the y's, leaving us with just negative 1 here. We then move on to the third term. Positive 15 divided by 5 is positive 3. X squared divided by x is equal to x to the 2 minus 1, which is x. And y to the 4th divided by y to the 3rd is equal to y to the 4 minus 3, which is 1. So we wind up with positive 3xy here. And the last term, negative 10 divided by 5 is negative 2. X to the 5th divided by x is x to the 5 minus 1, which is 4. And y to the 7th divided by y to the 3rd is equal to y to the 7 minus 3, which is y to the 4th. So we wind up factoring the polynomial into 5xy cubed times 4x squared minus 1 plus 3xy minus 2x to the 4th y to the 4th. And now to check the answer, we want to multiply our factors to confirm that we get a polynomial that matches our original polynomial, giving us 5 times 4, which is 20. X times x squared is x cubed, and we keep y to the 3rd. We then have 5 times negative 1, which is negative 5, and we keep x y cubed. We then have 5 times 3, which is 15. X times x is x squared, and y to the 3rd times y is y to the 4th. And then we have 5 times negative 2 is negative 10. X times x to the 4th is x to the 5th. And y to the 3rd times y to the 4th is y to the 7th. And since our final polynomial matches our original polynomial, that lets us know that we found the factors of that polynomial, which are 5xy cubed and 4x squared minus 1 plus 3xy minus 2x to the 4th y to the 4th. So that is how we factor a polynomial by removing the greatest common factor. Let's now discuss how we use the grouping method to factor polynomials with 4 terms. If a polynomial has 4 terms that do not have a common factor, then try factoring the expression by grouping the terms into pairs with common factors. So let's say we had the polynomial x cubed minus 5x squared plus 3x minus 15. There isn't a singular factor that can be removed from all 4 of these terms. However, if we group together the first 2 terms, x cubed minus 5x squared, they do have a common factor of x squared. And for the second pair of terms, if we group those together, they have a common factor of 3. So by grouping, we can actually create 2 sets of pairs, and they individually have a greatest common factor that can be removed. So you would be asked to factor by grouping and check the answer of x cubed minus 5x squared plus 3x minus 15. The first thing you want to do is create 2 groups with common factors. So we have one group here, x cubed minus 5x squared, that each have a common factor of x squared. And we have a second group here, 3x minus 15, that have a common factor of 3. And now that we've created 2 sets of terms, we want to remove the greatest common factor from both sets of terms. So from this set, we have a common term of x squared that can be removed. Once we remove x squared, the second factor will be the result of dividing this term by x squared, which will give us x cubed divided by x squared, which is x. And negative 5x squared divided by x squared is negative 5. Same thing with this set of terms. Once you remove 3, we can figure out the next factor by dividing each term here by 3, giving us 3x divided by 3, which is x. And negative 15 divided by 3 is negative 5. And now we have 2 different terms, one here, and we want to remove the greatest common factor. Both of them have a factor of x minus 5 that we can remove. When we remove x minus 5 from each one of these, we get x minus 5 as one factor. The second factor will be the remaining terms that were left once we removed x minus 5. So we combine x squared and positive 3 to give us our second factor. So when you factor x cubed minus 5x squared plus 3x minus 15, you'll get x squared plus 3 times x minus 5. And now the fourth step, you check the answer by multiplying the factors to confirm that these are the factors for our original polynomial. And when we do so, we get x squared times x, which is x cubed. Then we get x squared times negative 5, which is negative 5x squared. Then we have 3 times x, which is 3x. And we have 3 times negative 5, which is negative 15. So since our final polynomial matches our original polynomial, that confirms that we correctly factored it, giving us x squared plus 3 times x minus 5. Let's now have you try a few practice questions. Question number 1, factor by grouping 3x cubed minus 6x squared plus 15x minus 30, and then check the answer. Question number 2, factor by grouping 4x cubed plus 8x squared minus 9x minus 18, and then check the answer. In question number 3, factor by grouping 6x cubed minus 16x squared plus 21x minus 56, and then check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given 3x cubed minus 6x squared plus 15x minus 30. Step 1, create two groups with common factors. So we want to group together the first set of terms, and we want to group together the third and fourth terms. Why? 3x cubed minus 6x squared have a common factor of 3x squared. The coefficients have a common factor of 3. The variables have a common factor of x squared. When you divide 3x cubed by 3x squared, you get x. 3 divided by 3 is 1. X cubed divided by x squared is x. And when we divide the second term by the common factor, we get negative 6 divided by 3, which is negative 2. X squared divided by x squared is 1, so that cancels out. So 3x cubed minus 6x squared is equivalent to 3x squared times x minus 2. And we have 15x minus 30. We can remove 15 from each of these. 15x divided by 15 gives you x. And negative 30 divided by 15 is negative 2. So once we remove the greatest common factor from both sets of terms, we wind up with 3x squared times x minus 2 plus 15 times x minus 2. And we see that both of these terms have a common factor of x minus 2. So we want to remove that common factor, giving us x minus 2. And the remaining terms create a factor, 3x squared plus 15. Step 4, check the answer by multiplying the factors. The final polynomial that we get must match the original polynomial to confirm that these are the factors. When we multiply the factors, we get 3x squared times x, which is 3x cubed. Then we have 3x squared times negative 2, which gives us negative 6x squared. Then we have 15 times x, which gives us 15x. And lastly, we have 15 times negative 2, which gives us negative 30. And since our original polynomial and our final polynomial are matches, that confirms that we found the correct factors, which are 3x squared plus 15 and x minus 2. So that's the answer for question number 1. Let's now have a look at question number 2. We were given 4x cubed plus 8x squared minus 9x minus 18. Step 1, create two groups with common factors. Our first group we'll create with our first two terms. The second group we'll create will be with terms 3 and 4. So we put a pair of parentheses around the first two terms, add an addition sign, and then a pair of parentheses around terms 3 and 4. So the negative stays inside the parentheses here. And now step 2, remove the greatest common factor from both sets of terms. So 4x cubed plus 8x squared have a common factor of 4x squared. The coefficients 4 and 8 have a common factor of 4. The variables x cubed and x squared have a common factor of x squared. The second factor would then be 4x cubed divided by 4x squared, which would be x. 4 divided by 4 is 1. X cubed divided by x squared is x. 1 times x is x. Divide the second term by the common factor, giving us 8 divided by 4, which is 2. X squared divided by x squared is 1. So 2 times 1 is 2. So we get 4x squared times x plus 2 here. For our second set of terms, negative 9x minus 18 have a common factor of negative 9, which we remove, leaving us with negative 9x divided by negative 9, which is x, and negative 18 divided by negative 9 is positive 2 on the inside. And now we see here that x plus 2 is a common factor, so the third step is to remove that common factor from these terms, giving us x plus 2 as one factor, and 4x squared minus 9 as our second factor. So when we factor 4x cubed plus 8x squared minus 9x minus 18, we wind up with 4x squared minus 9 times x plus 2. And now we check the answer by multiplying the factors, and the polynomial that we get must match our original polynomial. So we get 4x squared times x, which is 4x cubed. We then get 4x squared times 2, which gives us 8x squared. Then we have negative 9 times x, which gives us negative 9x. And then we have negative 9 times positive 2, which gives us negative 18, thus confirming that our final polynomial matches our original polynomial, which means we found the correct factors, 4x squared minus 9 and x plus 2. So that is the answer to question number 2. Let's now have a look at question number 3. We were given 6x cubed minus 16x squared plus 21x minus 56. So the first step is to create two groups with common factors. So we'll group together the first two terms and group together the last two terms. 6x cubed minus 16x squared. The coefficients have a common factor of 2. The variables have a common factor of x squared, giving us 2x squared on the outside. And the second factor would then be 6 divided by 2, which is 3. X cubed divided by x squared is x. And negative 16 divided by 2 is negative 8. X squared divided by x squared is 1. So 1 times negative 8 is negative 8. So 6x cubed minus 16x squared gets broken down into 2x squared times 3x minus 8. And then we take a look at 21x minus 56. They have a common factor of 7. So the second factor for this group would be 21x divided by 7, which is 3x. And negative 56 divided by 7 is negative 8. So now we have a common factor of 3x minus 8. So we want to remove that common factor, giving us 3x minus 8 as one factor, and 2x squared plus 7 as our second factor. So 6x cubed minus 16x squared plus 21x minus 56 is equal to 2x squared plus 7 times 3x minus 8. And we can check the answer by multiplying these factors, giving us 2x squared times 3x, which is 6x cubed. 2x squared times negative 8 would give you negative 16x squared. 7 times 3x gives you 21x. And 7 times negative 8 is negative 56. So since our final polynomial matches our original polynomial, that confirms that the factors we wanted are 2x squared plus 7 and 3x minus 8. So that is how you would go about finding the factors of polynomials with 4 terms using the grouping method. Let's now have a look at trinomials. If the coefficient of x squared is 1, then the polynomial can be factored if the coefficient of x is equal to the sum of the factors of the constant. Now let's take a look at this a little bit further. Let's say we had x minus 3 as one factor and x plus 5 as a second factor. When we multiply these factors, we would get x times x, which is x squared, x times positive 5, which is 5x. Negative 3 times x would give us negative 3x. And negative 3 times positive 5 is negative 15. We can combine the like terms here. Positive 5x and negative 3x would give us positive 2x. We know that this can be factored because the coefficient of x, which is positive 2, is equal to the sum of the factors of the constant. The constant is negative 15. So we're looking for factors that have a sum of positive 2, and that would be positive 5 and negative 3. Negative 3 and positive 5 have a product of negative 15, and they have a sum of positive 2. So that is how we know the factors would be x minus 3 times x plus 5. So this is the general process you'll use to factor trinomials where the coefficient of the quadratic term is equal to 1. Not all of these trinomials will be factorable, but you know that the trinomial will be factorable if the coefficient of x is equal to the sum of the factors of the constant. So that's what we'll be looking out for. So let's say you're asked to factor and check the answer for x squared plus x minus 20. The first step is to consider the factors of negative 20 and to find the pair of factors that have a sum equal to the coefficient of x, which in this case would be positive 1. So we start with negative 1 times 20. That would give us a product of negative 20. But when we add those two factors together, we would get negative 1 plus 20, which is equal to positive 19. And that does not equal the coefficient of x, which is positive 1. So that is how we know that these are not the two factors of negative 20 that we are looking for. So then we look at the next pair of factors. That would be negative 2 times positive 10, which would also give us negative 20. When we add those two factors together, we get negative 2 plus 10, which is equal to positive 8. And that does not equal positive 1. So negative 2 and positive 10 are not the factors of negative 20 that we are looking for. We then consider the next pair of factors for negative 20, which would be negative 4 and positive 5. You'll notice that I made all of the smaller factors negative, since when we find the sum is going to be positive. So I'll let you know the larger factor of the two is going to be the positive one. But back to these. So we have negative 4 times 5, which gives us negative 20. When we find the sum of these two factors, we get negative 4 plus 5, and that equals positive 1. And that matches the coefficient of x. So now that we found the factors of negative 20, we want to add each of these factors to x inside a pair of parentheses. So we get x minus 4 as one factor, and x plus 5 as the second factor. And these are our factors for x squared plus x minus 20. And as usual, we can check the answer by multiplying the factors, x minus 4 times x plus 5. And if the final polynomial matches the original polynomial, then these are the correct factors. When we multiply them, we get x times x, which is x squared. X times 5 is 5x. Negative 4 times x is negative 4x. 5x minus 4x is equal to x. And negative 4 times 5 is equal to negative 20. So since the final polynomial matches the original polynomial, that lets us know that we found the correct factors. So x minus 4 times x plus 5 is equal to x squared plus x minus 20. So that is how you would go about factoring a trinomial when the coefficient of the quadratic term is equal to 1. Let's now have you try a few practice questions. Question number 1. Factor x squared plus 5x minus 14, and then check the answer. Question number 2. Factor x squared plus x minus 30, and then check the answer. Question number 3. Factor x squared minus 7x plus 12, and then check the answer. Pause the video, answer these 3 questions, and then press play when you are ready to begin. Question number 1. We were given x squared plus 5x minus 14. So we'll start by finding the factors of negative 14 that have a sum of positive 5. Negative 1 times 14 would give us negative 14. But when we find the sum of those two factors, we get negative 1 plus 14, which is positive 13, and that does not equal 5. So these are not the two factors that we are looking for. We'll then go to negative 2 times 7. That also equals negative 14. When we find the sum of these two factors, we get negative 2 plus 7, which is positive 5, which does match the coefficient of our x. So these are the two numbers that we're looking for. And now you add each of these factors to x inside a pair of parentheses, giving us the factors we were looking for, which are x minus 2 and x plus 7. And now to check this answer, we want to multiply the factors to make sure that we get x squared plus 5x minus 14. X times x would give you x squared. X times 7 gives you 7x. Negative 2 times x is negative 2x. 7x minus 2x is 5x. Negative 2 times 7 gives you negative 14. And since our final polynomial matches the original polynomial, that confirms that we found the correct factors, x minus 2 and x plus 7. Let's now have a look at question number 2. We were given x squared plus x minus 30. So step 1, find the factors of negative 30 that have a sum of positive 1. We'll start with negative 1 times 30, since that equals negative 30. When we find the sum of these two factors, we get negative 1 plus 30, which is equal to 29, and that does not equal 1, the coefficient of our x. So we then go to negative 2 times 15, which also equals negative 30. But when we find the sum of these two factors, we get negative 2 plus 15, which is positive 13, and that does not equal positive 1. So now we'll take a look at another set of factors that equal negative 30 when you multiply them. Negative 3 times 10. But when we find the sum of these two factors, we get negative 3 plus 10, which is positive 7, and that does not equal positive 1. So then we go to our final set of factors of negative 30, negative 5 times 6. And luckily, when we add them together, we see that we get positive 1, and that does match the coefficient of our x. So negative 5 and positive 6 are the two factors we were looking for. And now we add each of them to x inside a pair of parentheses, giving us x minus 5 and x plus 6. And now to confirm that these are the correct factors, we will multiply the factors to make sure the polynomial we get matches our original polynomial, x squared plus x minus 30. When we multiply the factors, we get x times x, which is x squared. We get x times 6, which is 6x. Negative 5 times x is negative 5x. 6x minus 5x is positive x. Negative 5 times 6 is negative 30. And we see that the final polynomial we get matches the original polynomial, thus confirming that the factors of x squared plus x minus 30 are equal to x minus 5 and x plus 6. Now let's have a look at question number 3. We're given the polynomial x squared minus 7x plus 12. So we want to find the factors of 12 that have a sum of negative 7. So we'll try negative 1 times negative 12, since that equals positive 12. I'm trying negative factors since their sum has to be negative. And two negatives times each other will give you a positive constant. That is why I tried two negatives. And when we find the sum of these two factors, we get negative 1 minus 12, which is negative 13. And that does not match the coefficient of our x, negative 7. So these are not the factors we are looking for. We then try negative 2 times negative 6, since that equals positive 12. But when we add them up, we get negative 2 minus 6, which is negative 8, and that does not equal negative 7. So we need to try two other factors of 12. So we'll try negative 3 times negative 4, which gives us a product of 12. And they give us a sum of negative 3 minus 4, which is negative 7, and that does match the coefficient of our x. So now we can add each of these factors to x inside a pair of parentheses, giving us x minus 3 and x minus 4. And now step 3, check the answer by multiplying the factors, giving us x times x, which is x squared. X times negative 4 is negative 4x. Negative 3 times x is negative 3x. And negative 4 minus 3x would give us negative 7x. And negative 3 times negative 4 gives us positive 12. And we see that our final polynomial matches our original polynomial, letting us know that we found the correct factors, x minus 3 and x minus 4. So that is how you would go about factoring trinomials where the lead coefficient is equal to 1. But how do we factor trinomials where the coefficient of our quadratic term is not equal to 1? Well, we are going to switch this polynomial from 3 terms to 4 terms. If a trinomial has a quadratic term with a coefficient that is not equal to 1, then it can be factored by grouping. So we have no common factor to remove. If we look at our numbers, for example, we have 2, negative 5, and negative 12. No common factor to remove. And we do not have x in each term, so we cannot remove x from each. So there's no common factor to remove. And as we mentioned, the leading coefficient is not equal to 1. So what we do is we focus on the middle term, negative 5x. The variable with a power of 1 must be split into two terms, so two groups of terms with common factors can be created. So this x has a power of 1, so this is the term we're focused on. And we're going to split negative 5x into two terms so that we can create two sets of terms. The two terms that we switch negative 5x to have a sum of negative 5x. So negative 8x plus 3x have a sum of negative 5x, the original term that was here. But by doing so, we now have one set of terms that can be grouped together and another set of terms that can be grouped together. And when we follow the grouping method, as we saw earlier in the chapter, we will wind up with the factors x minus 4 times 2x plus 3. But let's take a look at this process from start to finish to see how we land here. So you'll be asked to factor by grouping and check the answer for the polynomial 2x squared minus 5x minus 12, the expression we were just working with. So what do you do in these cases? Step 1, multiply a, the coefficient of your quadratic term, and c, your constant. So in this case, you'll be multiplying 2 times negative 12, which will give you negative 24. And now you want to find two factors of AC, which in this case is negative 24. You want to find the two factors of negative 24 that have a sum equal to b, which in this case is negative 5. So we'll start by looking at 1 times negative 24, since that has a product of negative 24. But the sum of these factors is 1 minus 24, which is equal to negative 23, and that does not match the coefficient of our x term, negative 5. So 1 and negative 24 are not the factors of negative 24 that we are looking for. So let's take a look at two other factors. 2 times negative 12 will give us negative 24, as we know. But when we find the sum of 2 and negative 12, that would be 2 minus 12, which is negative 10. And that does not equal negative 5. So 2 and negative 12 are not the factors that we are looking for. We then try 3 times negative 8, which also equals negative 24. And when we find the sum of these two factors, we get 3 minus 8, which is negative 5. And that does equal the coefficient of our x term, negative 5. So 3 and negative 8 are the factors that we are looking for. So we will break negative 5x into the sum of the factors, 3 and negative 8. So we wind up with 2x squared plus 3x minus 8x minus 12. 3x minus 8x equals negative 5x. And once we do this, we are left with two sets of terms that have a common factor that can be removed from each. So that's the fourth step, create two groups with common factors. 2x squared plus 3x have a common factor of x. And negative 8x minus 12 have a common factor of negative 4. So for each set of common factors, what you'll want to do is remove the greatest common factor from both sets of terms. Remove x here and negative 4 here. When we remove x and put that on the outside, the second factor for this term winds up being 2x squared divided by x, which would be 2x. And 3x divided by x would be 3. So x times 2x plus 3 is equivalent to this set of terms. And now here, negative 8x minus 12, we removed negative 4 from each, leaving us with negative 8x divided by negative 4, which is positive 2x. And negative 12 divided by negative 4 is positive 3. And now we have a common factor of 2x plus 3 in both these sets of terms. So step 6, remove the greatest common factor, 2x plus 3. And when we do so, we have a factor, 2x plus 3. And our second factor is x minus 4. So the factors of 2x squared minus 5x minus 12 are equal to x minus 4 and 2x plus 3. And now step 7, to check the answer, you want to multiply the factors. And the final polynomial that we get must be equal to 2x squared minus 5x minus 12. When we multiply the factors, we get x times 2x, which is 2x squared. X times 3 is 3x. Negative 4 times 2x is negative 8x. 3x minus 8x is negative 5x. And negative 4 times positive 3 is negative 12. So since our final polynomial matches our original polynomial, that confirms that we found the correct factors, x minus 4 and 2x plus 3. So that is how we go about factoring a trinomial by grouping terms. Let's now have you try a few practice questions. Question number 1, factor by grouping 2x squared plus 5x minus 3, and then check the answer. Question number 2, factor by grouping 3x squared minus 4x minus 4, and then check the answer. In question number 3, factor by grouping 5x squared plus 3x minus 2, and then check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given 2x squared plus 5x minus 3. Step 1, multiply a and c. So that would be 2 times negative 3. And that's equal to negative 6. Step 2, find the factors of a times c, or negative 6, that have a sum of b, or positive 5. Negative 1 times positive 6 equals negative 6. And when we find the sum of these two factors, we get negative 1 plus 6, which equals positive 5. And that does equal the coefficient of our x term, positive 5. So these are the two factors we're looking for, negative 1 and positive 6. So now step 3, separate b, 5 or 5x, into the sum of these factors, negative 1 and positive 6, x, giving us 2x squared minus 1x, or x, plus 6x minus 3. These two terms have a common factor that can be removed, and these two terms have a common factor that can be removed. So we create two groups with common factors by putting parentheses around each set of pairs. And then step 5, we remove the greatest common factor from both sets of terms. This set, we can remove x, giving us x on the outside. And the second factor would be 2x squared divided by x, which is 2x. And negative x divided by x would give us negative 1. So 2x squared minus x is equal to x times 2x minus 1. And for the second group, we have 6x minus 3, so we can remove 3, giving us 6x divided by 3, which is 2x on the inside. And negative 3 divided by 3 would give us negative 1 on the inside. And now we can remove the greatest common factor, which is 2x minus 1 in both of these terms, giving us 2x minus 1 as one factor, and x plus 3 as our second factor. And now step 7, check the answer by multiplying the factors, x plus 3 and 2x minus 1. Giving us x times 2x, which is 2x squared. X times negative 1 is negative x. 3 times 2x is positive 6x. Negative x plus 6x is positive 5x. And 3 times negative 1 is negative 3. So since our final polynomial matches our original polynomial, we found the correct factors, which are x plus 3 and 2x minus 1. That is the answer to question number 1. Let's now have a look at question number 2. We were given 3x squared minus 4x minus 4. Step 1, multiply a and c, 3 and negative 4, and that would give us a product of negative 12. And now we want to find the factors of a times c, or find the factors of negative 12, that have a sum of b, negative 4. So we'll start by multiplying positive 1 and negative 12 to give us negative 12. And when we find the sum, 1 minus 12 gives us negative 11, and that does not equal negative 4. So we'll need to take a look at another set of factors. 2 times negative 6 equals negative 12. And when we find the sum of these two factors, we get 2 minus 6, which equals negative 4. And that does equal negative 4, what we were looking for. So 2 and negative 6 are the factors of negative 12 that we were seeking out. And now the third step, we want to separate negative 4x into the sum of those factors, 2x and negative 6x. So we get 3x squared plus 2x minus 6x minus 4. These two terms have a common factor of x that can be removed, and these two terms have a common factor of negative 2 that can be removed. So we can create two groups with common factors by grouping those together, the first two terms and the last two terms. And now we can remove the greatest common factor from this set of terms and this set of terms. X is the greatest common factor here. When we remove x, the second factor winds up being 3x squared divided by x, which is 3x. And 2x divided by x would give us 2. And for our second group, we remove negative 2. The second factor on the inside would be equal to negative 6x divided by negative 2, which is positive 3x. And negative 4 divided by negative 2 is positive 2. So step 6, remove the greatest common factor from these two sets of terms. And the greatest common factor is 3x plus 2. That's common to both. So when we remove that factor from each of these, we get 3x plus 2 as one factor, and x minus 2 as our second factor. And now we want to check the answer by multiplying the factors to confirm that the final polynomial that we get matches the original polynomial. So we have x times 3x, which is 3x squared, x times 2, which is 2x, negative 2 times 3x is negative 6x, 2x minus 6x is negative 4x, and negative 2 times positive 2 is negative 4. And since our final polynomial matches the original polynomial, that confirms that x minus 2 and 3x plus 2 are the factors of 3x squared minus 4x minus 4. So that is the answer to question number 2. Let's now have a look at question number 3. We were given 5x squared plus 3x minus 2. Step 1, multiply a times c, 5 times negative 2, and that would give you negative 10. Step 2, find the factors of a times c, or negative 10, that have a sum of b, or positive 3. So we'll examine the factors of negative 10. We'll start with negative 1 times 10, since that equals negative 10. However, the sum of these two factors is negative 1 plus 10, which is positive 9, and that does not equal the coefficient of x, positive 3. So we'll look at another pair of factors that have a product of negative 10, negative 2 and positive 5. When we find the sum of these two factors, we get negative 2 plus 5, and that equals positive 3. And that does equal the coefficient of x. So these are the factors that we were looking for. So step 3, separate 3x into the sum of the factors, negative 2x and positive 5x. Now when we do so, we have 5x squared minus 2x plus 5x minus 2. The first two terms have a common factor of x that can be removed. But the second set of terms, 5x and negative 2, do not have the greatest common factor that can be removed. So since that is the case, we want to switch negative 2x and 5x. When we do that, the first two terms have a common factor of 5x that can be removed. And the second set of terms, negative 2x and negative 2, have a common factor of negative 2 that can be removed. So we create two groups with common factors by pairing 5x with 5x squared and negative 2x with negative 2. And then we can remove the greatest common factor from both sets of terms. In this first set of terms, the common factor that can be removed is 5x, leaving the second factor of this set of terms to be 5x squared divided by 5x would be 5 divided by 5, which is 1. X squared divided by x is x. 5x divided by 5x is positive 1. And now the second set of terms, we have a common factor of negative 2 that can be removed. So the second factor is equivalent to negative 2x divided by negative 2, which would just be x. And negative 2 divided by negative 2 is positive 1. So now we can remove the greatest common factor between this term and this term. And the greatest common factor is the factor x plus 1. We can remove it from both, giving us x plus 1 as one factor, and 5x minus 2 as the second factor. So 5x squared plus 3x minus 2 is equal to 5x minus 2 times x plus 1. In step 7, check the answer by multiplying the factors. When we multiply 5x minus 2 and x plus 1, we should get 5x squared plus 3x minus 2. 5x times x is 5x squared. 5x times 1 is 5x. Negative 2 times x is negative 2x. 5x minus 2x is positive 3x. And negative 2 times positive 1 is negative 2. Since our final polynomial matches the original polynomial, that confirms that 5x squared plus 3x minus 2 has the factors 5x minus 2 and x plus 1. So that is how we go about factoring trinomials by using the grouping method. Let's now discuss the sum and difference of two squares. The sum of two squares has two factors which are both imaginary numbers, and the difference of two squares has two factors which are both real numbers. So let's say we had two perfect squares, x squared and a squared, and we had the sum of these two squares. If you factor this polynomial, you would get x plus ai, the imaginary term, times x minus ai. And if the sum of the two squares is equal to 0, then you would find the values of x by setting each factor equal to 0 and solving for x. And that would show you that x has a value of negative ai, an imaginary term, and x is equal to positive ai, another imaginary term. Let's take a look at the sum of two squares using real numbers so that this can create a little bit more clarity. Let's say we were given x minus 2i times x plus 2i. If you were to FOIL this out, you would get x times x, which is x squared, x times positive 2i, which is positive 2xi. Negative 2i times x is negative 2xi, so these will cancel out. Negative 2i times positive 2i gives you negative 4i squared. So once these cancel out, we want to replace I squared with negative 1. Negative 4 times negative 1 gives you positive 4. So we see that these are the factors for the sum of two perfect squares. Now, because the sum of two perfect squares leads to roots that are imaginary, we will not be covering the sum of two squares in this chapter. To review the sum of two squares, click on the link at the top of the screen or in the comment section, and that will direct you to our chapter on complex numbers. Okay, for this chapter, we are going to focus on the difference of two squares. So let's say instead of addition, we had subtraction, and we had x squared minus a squared. If you were to factor this, you would get x plus a times x minus a. So if you set each factor equal to 0 and solve for x, we would see that x is equal to negative a real number, and x is equal to positive a real number. But let's take a look at this with real numbers so that we can gain a little bit of clarity. Let's say we had x plus 2 times x minus 2. If we FOIL this out, we would get x times x, which is x squared. X times negative 2 gives us negative 2x. Positive 2 times x gives us positive 2x. So these two terms will cancel each other out since they equal 0 together. And positive 2 times negative 2 is negative 4. And when these two terms cancel out, we are left with x squared minus 4. So we see the difference of two squares will lead to factors that have real numbers. So we see that for the difference of two perfect squares, we wind up with factors which are both real numbers. Now let's take this concept of the difference of two squares a bit further and discuss the coefficient. The coefficient of the quadratic term must be a perfect square, and the square root will be the coefficient of x in each factor. So you can factor the difference of two squares even if the coefficient of the quadratic term is not equal to 1. In this case, it's 4. So when we find the square root of this term, we would get the square root of 4, which is 2, and the square root of x squared, which is x. So 2x winds up being the first term in each factor. So when you are factoring the difference of two squares, consider the coefficient, and you find the square root of the coefficient the same way you would x squared, and that would be the first term inside each factor. Let's take a look at another example. Let's say we had 9x squared minus a squared. We take the square root of the first term. The square root of 9 is 3. The square root of x squared is x. So 3x is the first term in each factor. We have a plus in one factor, a minus in the other. Remember, these signs will be opposite. And the second term in each factor is equal to the square root of the second term in our polynomial. So the square root of a squared is a. So we see when we factor 9x squared minus a squared, we would get 3x plus a times 3x minus a. So the coefficient of the quadratic term is one thing to keep in mind. Another thing you should keep in mind, there are some situations you'll need to remove a factor first in order to create the difference of two perfect squares. So a common factor can be removed from each term to convert the polynomial into two perfect squares. So here we have 18x squared minus 8. 18 is not a perfect square. 8 is not a perfect square. But 9 is, and so is 4. So that lets us know that if we can cut each of these in half, we would get the difference of two perfect squares. So we want to remove 2 from each of these terms. 18 divided by 2 would give us 9, x squared, minus 8 divided by 2, which would be minus 4. Once we remove that factor, now we have the difference of two squares. And we would proceed, just as we did previously, by breaking this up into two factors. So again, keep the coefficient of the quadratic term in mind, and also keep in mind that you may have to remove a factor from the polynomial in order to create the difference of two perfect squares. Now let's go through factoring the difference of two squares step by step. Let's say you were asked to factor and check the answer for 4x squared minus 16. So we have the difference of two perfect squares. Step 1, create two sets of parentheses. Step 2, place a positive sign in one factor and a negative sign in the other factor. And now the third step, add the square root of the first term to the left side of each factor. So the first term we have is 4x squared. The square root of 4 is 2. The square root of x squared is x. So 2x is the first term in each factor. We put that on the left side of each factor. And now we take a look at the second term. The square root of 16 is 4. So we'll add the square root of the second term to the right side of each factor. So our final answer is The factors of 4x squared minus 16 are 2x plus 4 and 2x minus 4. And now we can check this answer by multiplying the factors. The final polynomial should be the original polynomial. That would confirm that these are in fact the factors. 2x times 2x gives us 4x squared. 2x times negative 4 is negative 8x. Positive 4 times 2x is positive 8x. Positive 8x and negative 8x cancel each other out. And positive 4 times negative 4 is negative 16. So we see that the final polynomial matches the original polynomial, which confirms that 2x plus 4 times 2x minus 4 are the factors that will give you a product of 4x squared minus 16. So that is how you go about factoring the difference of two squares. Let's now have you complete a few practice questions. Question number 1, factor x squared minus 49 and check the answer. Question number 2, factor 9x squared minus 36 and check the answer. And question number 3, factor 32x squared minus 50 and check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given x squared minus 49. Step 1, create two sets of parentheses. This is where we'll place our factors. The next step, we want to place a positive sign in one factor and a negative sign in the other factor. And now step 3, we want to add the square root of the first term to the left side of each factor. The first term is x squared. The square root of x squared is x. So that's the first term in each factor on the left side. And now we look at the second term. The square root of 49 is 7. So we place the square root of the second term to the right side of each factor. So we see that when we factor x squared minus 49, we get x plus 7 times x minus 7. And now we can check the answer by multiplying the factors. The final polynomial should match the original polynomial. So we get x times x, which is x squared. Then we have x times negative 7, which is negative 7x. Then we move on to the next term and we get 7 times x, which is positive 7x. These two terms cancel out. And we have 7 times negative 7, which is negative 49. So since the final polynomial matches the original polynomial, that confirms that x plus 7 and x minus 7 are the factors of x squared minus 49. Question number 2, we were given 9x squared minus 36. Step 1, create two sets of parentheses for our factors. Step 2, place a positive sign in one factor and a negative sign in the other factor. Then we want to move on to evaluating the terms of the polynomial. So step 3, add the square root of the first term to the left side of each factor. The square root of 9 is 3. The square root of x squared is x. So 3x is on the left side of each factor. Step 4, add the square root of the second term to the right side of each factor. The square root of 36 is 6. So we add 6 to both factors. And we see that when we factor 9x squared minus 36, we get 3x plus 6 times 3x minus 6. And now to check the answer, we want to multiply the factors to make sure that we get 9x squared minus 36 when we do so. So we get 3x times 3x, which is 9x squared. We get 3x times negative 6, which is negative 18x. 6 times 3x is positive 18x. These two terms cancel each other out. And lastly, we have 6 times negative 6, which is negative 36. So since the final polynomial matches the original polynomial, that confirms that 9x squared minus 36 is equal to 3x plus 6 times 3x minus 6. And now question number 3. We were given 32x squared minus 50. We'll notice that 32 is not a perfect square and neither is 50. But if we were to cut each one of these in half, we would get 16 and 25. So that's the clue that we need to let us know that we want to remove a common factor from each term, which in this case is 2. 2 times 16 would give you 32. 2 times 25 would give you 50. So once we remove the common factor 2, we are left with 16x squared minus 25, and that is the difference of 2 squares. So now we can proceed with the normal steps. So step 2, create 2 sets of parentheses so that we can factor this part of our expression. And now step 3, place a positive sign in one factor and a negative sign in the other factor. And now we take a look at the first term inside the parentheses here, 16x squared. And we want to add the square root of the first term to the left side of each factor. The square root of 16 is 4, and the square root of x squared is x. So 4x is on the left side of each factor. The square root of 25 is 5. So we add the square root of the second term to the right side of each factor. And once we've done so, we see that 32x squared minus 50 is equal to 2 times 4x plus 5 times 4x minus 5. And now to check the answer, we want to multiply the factors. So we'll start by multiplying the expressions inside the parentheses. 4x times 4x is 16x squared. 4x times negative 5 is negative 20x. 5 times 4x is positive 20x. Those will cancel each other out. And positive 5 times negative 5 is negative 25. And once we distribute the 2 to each of these terms, 2 times 16 would give us 32x squared. And 2 times negative 25 would give us negative 50. So since the final polynomial matches the original polynomial, that confirms that we found the factors, which are 2, 4x plus 5, and 4x minus 5. So that is how you go about factoring the difference of 2 squares. Let's wrap up the chapter by discussing 2 cubes, and we'll start by reviewing how to factor the sum of 2 cubes. The sum of 2 cubes can be factored into the product of a first-degree binomial and a quadratic trinomial. So this is slightly more complex than the sum and difference of 2 squares. So let's say we had 2 cubes, x cubed plus a cubed. This would be equal to x plus a times x squared minus xa plus a squared. I recommend that you commit this formula to memory. It will make factoring the sum of 2 cubes a heck of a lot easier. And let's break this formula down a bit more so it can become that much clearer. Here we have the sum of 2 cubes. This sign will always match the sign in the first factor. So if you're adding the 2 cubes, your first factor will be the cube root of the first term plus the cube root of the second term. See that? The next thing you'll notice, the second sign in our factors, first sign, second sign, will always be different than the sign being used in the original polynomial. So the first sign is the same as the one in our polynomial. The second sign is different than the one in our polynomial. And the last sign is always positive. So again, x plus a times x squared minus xa plus a squared. First thing to keep in mind are the signs. Now before we get into an example, let's first review a few perfect cubes. This will help you get familiar with the types of numbers that you are likely to encounter in these problems. 1 cubed is equal to 1. 2 times 2 times 2 is equal to 8. 3 times 3 times 3 is equal to 27. 4 cubed is equal to 64. 5 cubed is equal to 125. 6 cubed is equal to 216. I would suspect that most of your problems are going to end around here, but you should know at least through 10, I would recommend, ideally 12. And I think it's unlikely that you'll get a question from your teacher that goes beyond this, because then the numbers just get so high that it's not even beneficial to testing your knowledge of the subject matter. But again, I would recommend at least knowing through 10, ideally through 12, and you should be covered. 7 cubed is 343. 8 cubed is equal to 512. 9 cubed is equal to 729. 10 cubed is equal to 1000. 11 cubed is equal to 1331. And 12 cubed is equal to 1728. Now these are all the positive cubes. If you have negative, the final cube will be negative as well, since you're multiplying the factor 3 times. A negative times a negative is positive, but when you multiply it times a third negative, the final product is negative. So let's now take a look at an example. Let's say you were asked to factor and check the answer for x cubed plus 8. How we go about factoring the sum of two cubes. Step 1, add the cube root of each term to the first factor. So the first term is x cubed. The cube root of x cubed is equal to x. So x is in our first factor. Then we have positive 8. The cube root of positive 8 is equal to 2. So x plus 2 is our first factor. And now the second step, we want to add the square of each cube root to the second factor. So the cube root of the first term, the cube root is equal to x. So when you square that, you get x squared. That'll be the first term in our second factor. And then we want to add the square of this cube root as well. The cube root of 8 is equal to 2. When we square 2, we get 4. We'll place this at the end of the second factor. And now step 3, add the negative product of the cube roots to the second factor. That'll go here. So it's the negative product. So we have x times 2, which will give us 2x. So here in the middle, we want the negative product, which would be negative 2x. So when we factor x cubed plus 8, we wind up with x plus 2 times x squared minus 2x plus 4. And I place the negative product of the cube roots in the middle so that we have this trinomial in standard form. That is why I did it that way. But technically, x squared plus 4 minus 2x is the same thing. I just like having the second factor in standard form. Now, step 4, you can check the answer by multiplying the factors here. And we should wind up with x cubed plus 8 as the final polynomial. So when we multiply the factors, we get x times x squared, which is x cubed. X times negative 2x is negative 2x squared. X times 4 is positive 4x. 2 times x squared is positive 2x squared. I'll place that down here since these two terms will wind up canceling each other out. 2 times negative 2x is negative 4x. I'll place that here since these two terms will cancel each other out. And 2 times 4 is equal to 8. So we are left with x cubed plus 8 as our final polynomial, which confirms that x plus 2 is one factor, and x squared minus 2x plus 4 is our second factor. So that is how you would go about factoring the sum of two cubes. Let's now have you try a few practice questions. Question number 1. Factor x cubed plus 64 and check the answer. Question number 2. Factor 8x cubed plus 27 and check the answer. Question number 3. Factor 64x cubed plus 125 and check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given x cubed plus 64. Step 1, add the cube root of each term to the first factor. The cube root of x cubed is equal to x, so x is a part of the first factor. Our second term is positive 64. The cube root of 64 is equal to 4. 4 times 4 is 16, times 4 is 64. So 4 is the second term in our first factor. So our first factor is x plus 4. Now, step 2, we want to add the square of each cube root to the second factor. The first cube root is x. When you square that, you get x squared. The second cube root was 4. When you square that, you get positive 16. Place that at the end of the second factor. Step 3, add the negative product of the cube roots to the second factor. The product of the cube roots is x times 4, which is 4x. So the negative product is negative 4x, and we place that in the second factor. So when we factor x cubed plus 64, we wind up with x plus 4 as one factor, and x squared minus 4x plus 16 as our second factor. And now step 4, check the answer by multiplying the factors. When we do so, the final polynomial must be x cubed plus 64. So we multiply the factors, we get x times x squared, which is x cubed. X times negative 4x is negative 4x squared. X times 16 is positive 16x. 4 times x squared is positive 4x squared. 4 times negative 4x is negative 16x. 4 times 16 is positive 64. Negative 4x squared and positive 4x squared cancel each other out. Positive 16x and negative 16x cancel each other out, leaving us with x cubed plus 64, our original polynomial, thus confirming that once we factor x cubed plus 64, we will get x plus 4 times x squared minus 4x plus 16. So that is the answer to question number 1. Let's now have a look at question number 2. We were given 8x cubed plus 27. Step 1, add the cube root of each term to the first factor. Our first term is 8x cubed. The cube root of 8 is equal to 2, and the cube root of x cubed is equal to x. So 2x is the first term inside the first factor. The second term in our original polynomial is positive 27. The cube root of positive 27 is equal to 3. So our first factor is 2x plus 3. Now, step 2, add the square of each cube root to the second factor. Our first cube root was 2x. When we square that, we get 2 times 2, which is 4. X times x is x squared. Our second cube root was positive 3. When you square positive 3, you get positive 9. I'll place that at the end of the second factor. And now step 3, add the negative product of the cube roots to the second factor. The product of the cube roots is 2x times 3, which would be positive 6x. The negative product would then be negative 6x. So when we factor 8x cubed plus 27, we get 2x plus 3 times 4x squared minus 6x plus 9. And now, step 4, check the answer by multiplying the factors. When we do so, the final polynomial must be 8x cubed plus 27 to confirm that we found the correct factors. So we get 2x times 4x squared, which will give us 8x cubed. Then we have 2x times negative 6x, which will give us negative 12x squared. Then we have 2x times positive 9, which is positive 18x. Then we have 3 times 4x squared, which is positive 12x squared. So these terms will cancel each other out. 3 times negative 6x would give you negative 18x. That would cancel out with positive 18x. And positive 3 times positive 9 is positive 27. So once these four terms in the middle cancel each other out, we are left with 8x cubed plus 27, our original polynomial, thus confirming that we found the correct factors, 2x plus 3, and 4x squared minus 6x plus 9. In question number 3, we were given 64x cubed plus 125. Step 1, add the cube root of each term to the first factor. So we take a look at our first term, 64x cubed. The cube root of 64 is equal to 4. And the cube root of x cubed is equal to x. So 4x is the first term in our first factor. We then look at positive 125. The cube root of 125 is equal to 5. So our first factor is 4x plus 5. And now step 2, add the square of each cube root to the second factor. So when we square the first cube root, we get 4x times 4x, which will give us 16x squared. The second cube root was positive 5. When we square that, we get positive 25, which we'll place at the end of the second factor. And now step 3, add the negative product of the cube roots to the second factor. The cube roots are 4x times 5, so the product would be 20x. The negative product would then be negative 20x. So when we factor 64x cubed plus 125, we wind up with 4x plus 5 times 16x squared minus 20x plus 25. And now step 4, we can check the answer by multiplying the factors. Our final polynomial must be 64x cubed plus 125. So we get 4x times 16x squared, which will give you 64x cubed. 4x times negative 20x is equal to negative 80x squared. 4x times positive 25 is positive 100x. 5 times 16x squared would give you positive 80x squared, which cancels out negative 80x squared. 5 times negative 20x is negative 100x, which cancels out with positive 100x. And 5 times 25 is positive 125, leaving us with 64x cubed plus 125, our original polynomial, and thus confirming that we found the correct factors, 4x plus 5 and 16x squared minus 20x plus 25. So that is how we go about factoring the sum of two cubes. Let's wrap up the chapter by discussing how we go about factoring the difference of two cubes. This process is very similar to the sum of two cubes. The difference of two cubes can be factored into the product of a first-degree binomial and a quadratic trinomial. So we have x cubed minus a cubed is equal to x minus a times x squared plus xa plus a squared. So we'll notice, again, the first sign in the first factor is the same as the sign in our original polynomial. When we were adding two cubes, the first factor had addition. Since we're subtracting here, we have subtraction here. The second sign, or the first sign in the second factor, is always going to be different than the sign in the original polynomial. So here we have a negative, So in the second factor, we have a positive. And the last sign in our second factor is always going to be positive. So let's take a look at this with a real example. Let's say you were asked to factor and check the answer for x cubed minus 27. Step 1, add the cube root of each term to the first factor. So we have x cubed. The cube root of x cubed is equal to x. So that's the first term in our first factor. We have negative 27. The cube root of negative 27 is equal to negative 3. So our first factor is x minus 3. And step 2, add the square of each cube root to the second factor. The first cube root was x. When we square this, we get x squared. The second cube root was negative 3. When we square this, we get positive 9. I'll place that at the end of the second factor. And now step 3, add the negative product of the cube roots to the second factor. The product of the cube roots is x times negative 3, so that would be negative 3x. The negative product would then be positive 3x. So when we factor x cubed minus 27, we get x minus 3 times x squared plus 3x plus 9. And we see the first sign in our first factor matches the sign in the original polynomial. The second sign is opposite from the original sign. And the last sign is always positive. So those are correct as well, giving us a little bit of added confidence that we did this correctly. But to confirm that we found the correct factors, you can check the answer by multiplying the factors. When you do so, the final polynomial must match the original polynomial, x cubed minus 27. So when we multiply the factors, we get x times x squared, which is x cubed. X times positive 3x is positive 3x squared. X times positive 9 is positive 9x. Negative 3 times x squared is negative 3x squared, which cancels out positive 3x squared. Negative 3 times positive 3x is negative 9x, which negates positive 9x. And negative 3 times positive 9 is negative 27. So when we multiply the factors, we wind up with x cubed minus 27, the original polynomial. And that confirms that the factors were indeed x minus 3 and x squared plus 3x plus 9. So that is how you would go about factoring the difference of two cubes. Let's wrap things up by having you complete a few practice questions. Question number 1. Factor x cubed minus 216 and check the answer. Question number 2. Factor 27x cubed minus 64 and check the answer. And question number 3. Factor 16x cubed minus 54 and check the answer. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we were given x cubed minus 216. Step 1, add the cube root of each term to the first factor. So we first take the cube root of x cubed, which will give us x, and that's the first part of our first factor. We then examine negative 216. The cube root of negative 216 is equal to negative 6. So when we add that to the first factor, we get x minus 6 as our first factor. And now step 2, add the square of each cube root to the second factor. Our first cube root was x, so when we square that cube root, we get x squared. Our second cube root was negative 6. When we square negative 6, we get positive 36. And now we can take a look at step 3, which is to add the negative product of the cube roots to the second factor here. Well, if we multiply the cube roots, we get x times -6, which would be -6x. So the negative product would be positive 6x. So when we factor x cubed minus 216, we wind up with x minus 6 times x squared plus 6x plus 36. And now to confirm that we found the correct factors of x cubed minus 216, we'll multiply these factors, and we need to get x cubed minus 216 as the resulting polynomial. So we get x times x squared, which is x cubed. X times positive 6x is positive 6x squared. X times 36 is 36x. Negative 6 times x squared is negative 6x squared, which cancels out positive 6x squared. Negative 6 times positive 36 is negative 36x, which cancels out positive 36x. And negative 6 times positive 36 is negative 216. So when these middle terms cancel each other out, we are left with x cubed minus 216, which was the original polynomial, thus confirming that the factors of this polynomial are x minus 6 and x squared plus 6x plus 36. So that is the answer to question number 1. Let's have a look at question number 2. We were given 27x cubed minus 64. Step 1, add the cube root of each term to the first factor. So we have 27x cubed. The cube root of 27 is equal to 3. And the cube root of x cubed is equal to x. So 3x is the first term in the first factor. Then we examine negative 64. The cube root of negative 64 is equal to negative 4. So we add that to the first factor. We see that the first factor is 3x minus 4. Step 2, add the square of each cube root to the second factor. Our first cube root was 3x. If we square this, we get 3 times 3, which is 9. X times x is x squared. So we get 9x squared in the second factor. Our second cube root was negative 4. When we square negative 4, we get positive 16. So we add that to the second factor. Step 3, add the negative product of the cube roots to the second factor. The product of the cube roots is 3x times negative 4, which is negative 12x. So the negative product would be negative 1 times negative 12x, which would give you positive 12x. So when you factor 27x cubed minus 64, you get 3x minus 4 times 9x squared plus 12x plus 16. And you can check the answer by multiplying the factors. And if we get 27x cubed minus 64, that would confirm that these are the factors for this polynomial. So we get 3x times 9x squared, which is 27x cubed. 3x times 12x is positive 36x squared. 3x times positive 16 is positive 48x. Negative 4 times 9 is negative 36x squared. That will negate positive 36x squared. Negative 4 times positive 12 is negative 48x. That will cancel out positive 48x. And negative 4 times 16 is negative 64. So when the middle terms negate each other, you are left with 27x cubed minus 64, which was the original polynomial, thus confirming that you can factor this expression to 3x minus 4 times 9x squared plus 12x plus 16. In question number 3, we were given 16x cubed minus 54. but we'll notice that 54 is not a cube root and neither is 16. So that is a clue that we'll need to remove a common factor from each term, and that common factor is 2. When we do so, 16 divided by 2 is 8, and negative 54 divided by 2 is negative 27. 8 is a cube, 2 times 2 times 2. Negative 27 is a cube, negative 3 times negative 3 times negative 3. So we see here that we created the difference of two cubes, and now we can proceed the way we normally would. So step 2, add the cube root of each term to the first factor. So we have 8x cubed. The cube root of 8 is 2. And the cube root of x cubed is x. So that gives us 2x in this factor here. Then we look at negative 27. The cube root of negative 27 is equal to negative 3. So we add that to the factor as well. And now step 3, add the square of each cube root to the second factor. So our first cube root was 2x. So the square of that cube root would be 2x times 2x, which is 4x squared. Our second cube root was negative 3. So if we square that, that will give us positive 9, which we'll add in this factor here. And now step 4, add the negative product of the cube roots to the second factor. We have 2x times negative 3, which would give us negative 6x. So the negative product would be positive 6x. So when we factor 16x cubed minus 54, we wind up with 2 times 2x minus 3 times 4x squared plus 6x plus 9. In the last step, we can check the answer by multiplying the factors. And if we get 16x cubed minus 54, the original polynomial, then we'll know that we found the factors correctly. So we'll first multiply the expressions inside the parentheses, giving us 2x times 4x squared, which is 8x cubed. 2x times 6x is 12x squared. 2x times positive 9 is 18x. Negative 3 times 4x squared is negative 12x squared, which will cancel out positive 12x squared. Negative 3 times positive 6x is negative 18x, which cancels out positive 18x. And negative 3 times positive 9 is negative 27. So we multiply the two factors inside the parentheses. We get 8x cubed minus 27 inside the parentheses times 2. And when we distribute the 2, we get 16x cubed minus 54, the original polynomial, thus confirming that when we factor this expression, you'll get 2 times 2x minus 3 times 4x squared plus 6x plus 9. And that wraps up this chapter on factoring polynomials. Should you have any follow-up questions, feel free to leave them in the comment section. Or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.